Assalamu alaikum. It's our particle physics lecture from Griffith's book, chapter number 5. We are going to solve problem number 5.2, in which it says use equation, this which I wrote on the board, where A is equals to h cut divided by me square, which is approximately equals to 0.529 into 10 raised to power minus 8 meters. Okay, here is the question you can see. To obtain around state ground state wave function psi 100, okay, 100, show that it satisfies the Schrodinger equation, which is minus h cut square by 2m delta square plus v multiplies by psi equals to iota h cut partial by partial t psi with approximate energy, and check it is properly normalized. Okay, so this question we have to solve today. So let's start our problem. First of all, have to find the wave function for psi 10. So let's move towards the solution. So we can start solution by find, because we have to find the psi 100. Here you know that n is equals to 1, okay, whereas your l equals to 0, second term is l, and your ml equals to 0 again. Here this is n l and this is ml. So what you have to do, you have to just initialize these value into your main equation. So once we put the values, you can see here it becomes 2 divided by n becomes 1 a, okay, here is bracket cube, again 1 minus 0 minus 1 divided by, okay, here what you can see, here you can write it as like this, like 1 minus 0 minus 1 factorial divided by 2 into 1 bracket 1 plus 0 to cube, okay, power 1 by 2, again e power minus r divided by 1a because n value is 1, and 2r divided by again 1a power 0, again l 2 into 0 plus 1, 1 minus 0 minus 1, it becomes 2r divided by 1a multiplies by y, 0 0 theta phi e power minus iota e1t divided by h cut. Understood? We just put it these three values in our main equation. So after doing that, you will get your results, and your final results of this is it becomes 2 by a whole cube 1 by 2 bracket power 1 by 2 e power minus r by a l 0 1, okay, and you will get this becomes 1, and you will get with this 2r divided by a and y 0 0 function of theta phi e power minus iota e1t divided by h cut. Now you know that the value of L01 is basically equals to 1, whereas your y00, which is the spherical harmonics, it is equals to 1 by under root 4 pi. These are the constants. Now putting these values, you will get your wave function psi 100 is equals to 2 divided by a power 3 by 2 dot e power minus r by a dot 1 by 2 under root pi e power minus iota h cut minus iota e1t divided by h cut. Understood? And you will get your final result for the case of psi 100, and that is equals to 1 divided by under root pi a cube. Just substitute these values and get your final result, and your final result is this. E1t divided by h cut. This is your results of psi 1 0 0. Understood? Now what you have to do, you also know that E1, because here is E1, you know that E1 equals to minus m e power 4 divided by 2 h cut square. You have to put this, and before that you also, now here you know that del square your function with r equals to, this is the formula, 1 by r square and g by dr, okay, which is r square df divided by dr. So what you have to do, you just have to multiply your wave function with del square, so it becomes del square psi 100 becomes 1 by under root pi a power 3, okay, which is then becomes e power minus iota e1t divided by h cut. 1 by r square is as it is. First of all, you put your value of this, you can see, and 1 by r square, then d by dr, then what you have to do, r square df by dr. It is same thing, okay, I just put it my value here. Now what you have to do, take the derivative, okay. How you can take the derivative, you can take the derivative here, you can use product rule, okay. So how you can take the derivative, so it becomes 1 by under root pi a cube e power minus iota e1t divided by h cut, okay, dot 1 by r square here, again d by dr, it becomes r square. And you know that your function is basically, you have to take the derivative of f, and you know that the function is this. So taking the derivative of your function is this, okay. By taking the derivative, these all you can see are constants. Before e power iota, this constant, because there is no r term inside, only the r term is here, so you can take the derivative of this. So taking the derivative is become minus r by a or 1 by a, by taking the derivative of minus 1 by a, okay, by taking the derivative of the exponential power. So these are your results. It finalizes, it goes, and we can write here the next steps. So it converts, it becomes 1 by under root pi a cube e power minus iota e1t divided by h cut, okay, minus 1 by or a 1 by r square minus 1 by a, which comes from here, okay, 1 by r square dot d by dr, inside becomes r square e power minus r by a. Now again you have to take the product rule here. What it becomes, pi a cube e power minus iota e1t divided by h cut, okay, minus 1 by a 1 by r square, and it become, taking the product rule becomes 2r e power minus r by a minus 1 by a e power minus r by a dot r square, okay, which reduces, this is, and this you can see, okay, and taking e power minus r by a from common, and this reduces to psi 100, and remaining terms is 1 by a square minus 2 by ar. So this is your result of del square of psi 100, which is equals to this relation, okay. Now you have to show the Schrodinger wave equation, which you know that what is Schrodinger equation. Let me show here. You know that minus h cut square by 2m plus v multiplies by psi equals to iota h cut partial by partial t psi. Now what you have to do, you have to first solve the left hand side, then the right hand side. Okay, you also know some other factors is you also know that v is equals to minus e square by r, and you also know that a is equals to h cut square by me square. If you want to find e square, your e square becomes equals to h cut square by am. So now first let's solve the left hand side of the Schrodinger equation. What you have to do, you just have to put the value of v, which is this minus e square by r, and you have to put the value of psi, which we find okay before. Here you can see. So now your equation of Schrodinger equation left hand side becomes minus h cut square by 2m. Okay, taking common, minus h cut square by 2m multiplies by psi multiplies by 1 by a square. Okay, minus 2 by ar psi 100, because you can see minus h cut square 2m multiplied by psi, so minus h cut square by 2m multiplied by the whole value of psi, which is this. Again minus this, you can see. Okay, v, it multiplies by v, so it becomes, the v value is this, so it becomes minus e square by r psi 100, because v is also multiplied by psi, so it is this. So it reduces, just multiply, and you will get final relation minus h cut square by 2 ma psi 100 plus 2 h cut square by 2 mar. Just multiply psi 100 minus e square by r. Here is also psi 100, multiply. Understood? Now what you can do, you can just put the values, and you know that the value of e is h cut square by am. Just put the value of e h cut square by 2m here, but left, this cancels with this. Okay, after putting the value. So let me show you how you can get this. Becomes minus h cut square by 2ma square. Okay, psi 100 plus h cut square psi 100 divided by mar, which is this relation. Okay, now by putting the value of e square, which I mentioned here, the value of e square is h cut square by am, so it becomes minus h cut square by psi 100 divided by mar, so it cancels with this, and you will only left with minus h cut square by 2m h power 4 h cut power 4 me square whole square psi 100, which more reduces to minus me4 divided by 2 h cut square psi 100. So this is the result of left hand side of solving the Schrodinger equation. Now what you have to do, you have to do the, to solve the right hand side of the Schrodinger equation. As you know that the right hand side is iota h cut partial by partial t psi. Now what you have to do, you have to put iota h cut partial by partial t psi 100, so it becomes iota h cut. Our psi relation in term of t is, you know that, minus iota e1 t divided by h cut, because you know that the time term is only this, okay, this, it becomes psi 100. Again it, after h cut cancels with h cut, iota multiplied by iota square means minus 1 multiplied by minus 1 become plus 1, so you will only left with e1 psi 100. Now you just have to put the value of E1. You know that what is the value of E1. As I mentioned here, the value of E1, here you can see, putting the value, you will minus me4 divided by 2 h square psi 100. So you can see that your right hand side equals to the left hand side. Thus your Schrodinger equation is satisfied, which we required in our problem. Now our final step is to normalize our equation. So how we can normalize? We know that for this scenario we have to take the mod square of psi r square sine of theta dr d theta d phi always equals to 1, whereas you also know that your psi 100 mod square is equals to 1 by pi a cube e power minus 2r divided by a, by taking the mod square of this psi. So under root cancels and here you will get with minus 2ar. Okay, this you will okay, not introduce the time term, you will only introduce the r term. Or you also know that your sine theta means d theta or d phi term always equals to 4 pi. This is the constant value you must have to know. By putting psi mod square here and this here, also r square is already there, so you will reduce your equation and your equation will converge into, after putting value, 1 by pi a cube 4 pi zeros to infinity e power minus 2r by a dot r square. Here r square is as it is, e power to r, because you have, this is r terms, you have to integrate with respect to r. After integrating you will get your relation 4 by a cube, means a cube multiply a cube by 4, and you will get your final result, and your final result is equals to 1. So this is how you can solve this problem 5.2 of particle physics book Griffiths. And in this equation what you have to basically do to obtain the ground state of wave function psi 100, means the value of n is 1, l is 0, and ml is also 0, then you have to show that it satisfies the Schrodinger equation. You know that the Schrodinger equation is this. After putting the wave functions which we find it before, psi 100, have to initialize your wave function in your Schrodinger, first of all in left hand side, then right hand side. You have to satisfy your right hand side must be equals to left hand side, okay, by introducing psi 100 into the Schrodinger wave equation. Then to this is to show that to satisfy the Schrodinger wave equation, that's all. And lastly, what you have to do to check it properly normalized or not. So if your answer is 1, so you can say your wave function is normalized. Okay, because you know that wave function always normalized if the value is equals to 1. So that's all for this problem. So thanks for watching. Stay tuned with us. We will upload more interesting lectures of particle physics problems related questions. So for that, till then, take care. Allah Hafiz.